So let's take it step by step. Transcription. We are transcribing our DNA recipe, so to speak. This is when DNA is converted into messenger RNA. And this happens in the nucleus. We're transcribing. So the example I like to use is, let's say your recipe is in French and you need to get it into English in order to make your dish. This step, transcribing, would be from French to English. So here in transcription, we use specifically an RNA polymerase that will come in to the double helix and start to bind at a certain place. It will read the base strand of DNA and build a complementary RNA from it. The complementary part, and there's also a helicase that's going to help unwind this double helix and separate the two strands. And so it's important just to know that there's going to be a helicase that comes in here and it's going to separate the strands, so that then this polymerase can go in and start making a complementary strand of RNA. And when we say complementary, if the DNA has a C, it's going to make an mRNA with a G. If the DNA has a G, the mRNA will have a C, so forth and so on. T will give you an A, and an A, this is the big difference, because mRNA does not have a T, it's going to have a U. So from this, I should be able to give you any DNA sequence, and you should be able to write out the mRNA sequence correspondingly. So A, C, G, T, A would give you, for DNA, U, G, C, A, U, U. And this would be the RNA, complementary RNA. The first RNA that comes out of the RNA polymerase is considered immature. What this means is it's not quite ready yet. So let's say we converted our recipe from French to English, but let's pretend there were a lot more extraneous words in the French language that really amounted to gibberish in English and were unnecessary. And so we could call these introns. This extraneous information is removed, and the exons, the remaining words, are spliced together, and they'll make a final messenger RNA that we can use for making our dish. Here in your book, figure 4.6, you can see is a DNA with the pre-mRNA and then the official messenger RNA, as all of these introns are spliced out and the exons are fused together. This is called alternative splicing because these genetic sequences can be spliced, the introns can be removed in variations. So certain introns can be removed and other ones not, which means one genetic sequence can actually make several different proteins. So exons can be sliced together into a different mRNA from the one it was before, which gives us a lot of power because we can make different proteins using only one DNA base sequence.